Hello, everyone, and nice to see that so many people have joined. It's only me and one other talk between us and a beer, so great to see so many people here. And I hope that you enjoyed the first day of Container Days as much as I did. It's been like a great day and lots of interesting talks today. Um, my name is Simon Pearce, and I work for a company called Sys11. And I want to introduce you today with my topic, managing and securing Kubernetes secrets. So quickly about me and about Sys11. I've been working since 2013 at Sys11. Sys11 is a managed hosting company based in Berlin. We've been offering managed services for the past 15 years. So these are pre-cloud services on Parallels Virtuoso, cloud services on top of OpenStack. And since 2018, we've also been offering a managed Kubernetes product. We currently run about 300 Kubernetes clusters for various customers, the majority of them somewhere from Germany, Austria, or Switzerland, but we have a few other customers as well. Most of them because we are GDPR compliant. And if you want to talk about any of this later on, then please feel free to draw up by our booth. So my hobbies, anything basically Linux related. I like tinkering with Raspberry Pis and building setups at home if I'm not doing it at work. K3s and micro-K8s. And if I'm not doing anything of this and I feel energetic, I like going out to the forests of Brandenburg with my bike, cyclocrossing and gravel cycling. That's a great pastime. And also frees up your mind from all the Linux-related stuff and Kubernetes. So let's jump in and I'll quickly show you the agenda about what I'm going to talk today. So first is going to be Kubernetes secrets. What is the current situation? The majority of you have probably already experienced this, but I'll talk about this in a minute. The next thing will be securing secrets. So I would like to show you ways how you can secure your secrets maybe and improve the current situation. Unless, of course, you're okay with this, but I think most of you probably aren't, else you wouldn't be here today. And what options are existing, or what options exist for managing secrets? What can you actually use to get this task done? And then I'll briefly talk about external secrets and KMS, so key management servers or systems. And last but not least, I'll show you a quick demo about how you can solve these problems, or one way that you could solve these problems. Of course, this talk is opinionated. There's multiple ways of solving these problems. So, of course, I made a choice, which I would like to show you here today. There are definitely other choices, and if anyone would like to speak about this, either during the Q&A or later on at our booth. So, Kubernetes secrets, current situation. So I bet most of the people that adopted or started using Kubernetes here in this room probably encountered a base 64. And as the majority of you will probably know, base 64 is basically a way to encode secrets, but anyone that has access to this file, either in Git or in the Kubernetes cluster itself, can read these secrets and retrieve everything. It's like no form of encryption. When I first saw this, I was like okay, this is like not ready. How is anyone going to actually use this in production? And I think a lot of people are, but I don't think it's like the way forward that we should be running and managing secrets in now or in the future. So they're basically stored unencrypted in our K8s data store etcd. So every single Kubernetes cluster has its own etcd cluster. This is basically the source of truth for Kubernetes, and we store every single object in the etcd cluster, and also all of the secrets. So anyone that can access this etcd cluster, or any backups that you may have that could be on a volume, in an S3, or that your provider maybe even manages for you that you don't even know about, they could be accessed and anyone could retrieve all of your secrets. So this could include anything like TLS certificates and keys, registry secrets that you may need, pull secrets, or any other things that you need in your environment, like stuff, maybe any deployment tooling that you're using or anything else. So this is potentially dangerous and not good. In theory, anyone that can create a pod can also read a secret. So there's certain limitations that can be taken by RBAC. I will talk about this briefly later on. But in theory, anyone that can access a pod can also read the secret. Or anyone with access to the API server itself. So they can retrieve, or even, which is even worse in my opinion, modify a secret. So they can change any database passwords, anything else that you may have. So this is definitely not a good current situation, if you ask me, and needs improvement. So how can we go about improving this? So I tried to break this down into 2 ways that you can do this. And as I said, this is opinionated, but let's go through them. So securing secrets. So first, you can use access control RBAC. So RBAC is the role-based access control. It's basically built into all Kubernetes clusters. And as you've actively deactivated it in the API server, which I would not recommend, as you would also allow anonymous access to your API server if you do this. But this has been around, I think, early 1.10 or something. RBAC was introduced by Red Hat and works in all clusters. This will allow you to limit what someone can do. So you can limit this by namespaces with roles and role bindings, or to clusters with clusters and cluster roles. So you can use this. It's a very powerful tool. It only has one big disadvantage. It's not super easy to configure because you have to explicitly list up everything which is allowed. There's no deny policies. So it can be a bit cumbersome, but there are tools available to solve these problems. For instance, RBAC Manager by Fairwinds, you could use things like this to get this done. It's like a small operator you install in your cluster. So you can restrict secret access to specific containers. So only the containers that really need the database password get access to the database password. This is also something that you should do and should be aware about. Part of this can be done with service accounts. And a service account can, of course, also have a role and a role binding. Most of the Helm charts available already do this, but it's also something worth looking into. What is someone actually installing when you install one of these Helm charts? Have you checked it? Have you seen what roles or cluster roles you're actually getting? And if you see something that's assigning cluster admin, definitely all your alarm bells and whistles should go on. You can use encryption at rest for your etcd, which would prevent people from reading, if they get access to your etcd, data from your etcd cluster. This, of course, if you look at the standard Kubernetes documentation, there's multiple ways of doing this. The initial way this is explained is to have the keys to secure the etcd on the API server. If you ask me, this is not good enough because every attacker that accesses your API server is going to laugh out loud because he's taken over your API server, and next he gets all the encryption keys for your etcd because they're free, they're lying there on the same server. If you ask me, this is definitely not sufficient and not something that you should really be doing. There's ways of doing this externally, and there's a few software components available that allow you to store the encryption keys for etcd outside of your Kubernetes cluster. The next way that you can use is to use an external secret store, and this is one of the ways which I'm going to outline within my talk here, and which this talk evolves around because as I said, this is a personal opinion. I find this is the only right way that you should be dealing with secrets in production. Anything else is not really sufficient. So what options do we have for managing secrets? As I said, I broke this down into 2. So number 1, store the encrypted secret. So you can use something to encrypt your secrets when they're stored into Git. So basically, people would not be able to read the base64 files. They're all encrypted. You can put them in Git. They could even be theoretically in a public Git repository. I would not recommend doing this, but it's possible. And you decrypt them with a sealed secret when you go to deploy your secret into your Kubernetes cluster. This is a valid option, which you can do. And possible components you can use to do this would be Mozilla SOPs or from Bitnami sealed secrets. I find you're kind of just shifting this problem because you have like an operator running in the Kubernetes cluster that basically has an encryption key to decrypt all the secrets that you're pushing into. So you basically solve the Git side. The Git side's okay, this is encrypted. But then what happens if you break this operator? Then you've broken all your secrets. What happens if you lose this encryption key? Then everything's basically gone. And is this actually sufficient? And how are you going to rotate things and other things? I think this is better than the default situation, but for me personally, this is not going far enough to actually solve the problem in a production cluster. So I believe that storing a reference to a secret in your Git repository is the proper way to do this. So instead of actually having the secret and some base64 or encrypted secret in your Git repository, you have a reference to your secret. So there's a path which shows, okay, here's where I can retrieve my secret. So there's no way that anyone can interfere with this. The secret is created in the K8s cluster. It doesn't have to be, and I'll show you why not in a minute in the demo, but normally it is created, of course, also in the Kubernetes secret. So you still have the problems to solve with your etcd and the unencrypted stuff there. And normally the values are fetched from a external secret store. So there's multiple ways of doing this. I'll show you a list of secret stores that you can use. And to store these external secrets, the main possibilities are AWS. If you're running on AWS, they have their own KMS system, which you can use. It's like highly available. It can be used in all environments. I believe you can even use it outside of AWS as well. Google also have a similar KMS system in GCP. And there's Azure with their own Key Vault, which you can also use if you're running on top of Microsoft Azure. And up to now, what I would always recommend would either be like going with the HCP, so this is HashiCorp Cloud Platform, which also runs on top of Azure, or Vault self-hosted. So HashiCorp have slightly changed their licensing since well, not slightly, they basically really changed it. So they were running under the BSL license. So for normal use, this should not be a problem. If you're trying to sell Vault as a managed service or offer it for third parties, this may be a problem if you're a service provider yourself. But that's basically the way that you could go. And this is also what I'm going to show in this talk, how you can retrieve secrets from Vault. So how do you go about synchronizing external secrets? So you basically have the secret object in your KMS system, which you've written there, and then you want to synchronize it so your pods can use it in your Kubernetes cluster. So you can use the Vault agent sidecar injector. This is one option that you have. I don't really like the approach of sidecars too much, so this would not be something that I would primarily recommend, because I always find every time you run sidecars, similar with service meshes, you've got like your main container to update, and then you've got your sidecar to update. Your resource consumption also goes up as well, because with every single pod you deploy, you need to deploy a new sidecar. I don't always find this the best approach to actually solve this problem. But at the end of the day, it's up to you. I mean, a lot of people deploy service meshes in this way as well. But then again, you have a lot of overhead and things to take care. Every time you update your sidecar, because Vault might issue a new version, you will have to restart your main container. So this is definitely also a bit of a pain. You can use, if you're on an Argo CD, you could use the Argo CD Vault plugin. I've never used this myself, but I heard it works really well. And this would also allow you to retrieve secrets when you're deploying them with Argo. It's basically a plugin to extend functionality in Argo CD. You can use the external secrets operator. This was originally what I evolved my talk around, and I built everything around this external secrets operator until one of my colleagues showed me a software which I believe has like a certain feature which makes it a bit better than the external secrets operator. But the external secrets operator is also an awesome piece of software. It definitely does the job, and it also supports multiple backends. I think they're going for CNCF graduated as well, or they just graduated. I'm not exactly sure. I think so. And I built this talk around a solution called Secret Store CSI driver, and I'll show you why in a minute. This is a Kubernetes SIG project. So what I liked about this is that, number one, of course, it's a SIG project, and I like the idea that, which I'll show you in a minute, is how they utilize the CSI driver to store secrets. So what does the Secret Store CSI driver do? So in general, it syncs with Kubernetes secrets. So you can use it as a man in the middle between your Vault or any other KMS system that's supported. So this could be any of the other ones that I listed, and it will synchronize these to Kubernetes secrets. It mounts secrets to a pod using a CSI volume. So I'll show you this detailed in a minute. I have like a small picture you can have a look at, but it basically allows you to store secrets to a TempFS volume. You can also, if you need multiple secrets, so maybe you need like a database secret, but also pool secrets or other things, you can also mount multiple secret objects into a single TempFS volume, which is then attached to your pod, which I also find is a great feature. And you have support for multiple external secret store providers. So if you ever decide that, or your management may make the decision that you need to change your cloud platform, or for redundancy reasons, you need to set up more Kubernetes clusters in new cloud environments on different hyperscalers, you can basically reuse the same methods that you're already using. Because if you were like had clusters on AWS and Azure, you could utilize the KMS systems on both, and you can use the same way because external secrets would speak to both of them. There's only a few lines of code that you would actually be required to change. You've also got Linux and Windows container support. If any of you are running Windows containers with Kubernetes, this could also be interesting. And one of the things which I find is a really good feature is the automatic secret rotation. So the majority of you have probably experienced this before. People leave the team, new people join the team. Security have told you, okay, you need to rotate all of your secrets. If these are kind of being manually created, then this could be like a big job for you. Then you have to go through every single secret, find out, change them, and then also update the secrets within Kubernetes as well. So this could be like a real pain. And this can all be done from one source of truth. So this is basically what the setup looked like. So you have on the left-hand side, we have our kubelet, which takes care of starting and restarting all of our pods. Then we have the Secret Store CSI driver in between, which we install with the Helm chart. We'll do this in a minute. And then we use a gRPC call to call the Secret Store CSI provider with a service account that then is allowed to access Vault. So Vault has a option where you can allow it to do Kubernetes authentication. And this basically allows us then to use this service account, which we've configured prior, to retrieve the secret, and then the Secret Store CSI provider then writes this to the TempFS volume, which you can see in the box. So this is basically how all of this setup works. And as I said, the component on the right, HashiCorp Vault, can be changed for other components as well. This is not a problem at all. Okay, so to get all this running and to make sure that you understood what I've done, I did a bit of demo preparation prior to this talk. I set up well, we already had a lab cluster, so I'm using this to actually show this demo here today. I first did a bit of Kubernetes configuration, and number one, I installed the Nginx Ingress controller because we need this to publish our applications. Then I created a load balancer service on our OpenStack cloud. So this was created with the Ingress controller and the service type a load balancer. I installed JetStack's cert manager so we can get a TLS certificate to secure our application. Then I installed external DNS. So external DNS will automatically update the A record pointing to the domain that we'll be using in the demo. So this hopefully should all work. And we've got the HashiCorp Vault, which of course I installed before because this would take too long. And I also put a secret in there with CSI secrets enabled. So you need to activate this in the Helm chart. I'll quickly show you this in a minute. And I built, no, actually I didn't build it. Actually, ChatGPT built two Golang applications for me to show you how you can actually retrieve the secrets and how this may look at. So, Vault configuration. What do you need to do in Vault? So in Vault, you basically need to configure Vault. I did it with a Terraform provider. There's other ways that you could do this, but HashiCorp provide a Terraform provider to do this, which is really easy. I set up Kubernetes authentication. Kubernetes authentication basically allows you to specify a Kubernetes API endpoint or a load balancer in front of multiple masters to authenticate, and you can also give them your CA certificate. Then we have an auth role. An auth role binds to a service account in a specific namespace. So only the service account in that namespace can access the secret that we're writing. And we also have a policy to access the secret. So Vault has a concept of policies, and you can basically, they can be very open. You can allow someone or some service account to have access to multiple secrets if you want, but you can also drill this down so someone only has access to exactly the secret it needs. This is possible. I didn't actually do this for this demo, but I'll show you the policy in a minute. So let's have a demo, and I'll show you how I set this all up. So if anyone can't see this, then please let me know if it's not big enough. I'll try and increase the size. In the back, can you see this? Okay, I'll make it even bigger then. Okay, oops. Oh, okay, so number one was the access. So access, as I said, is done by Kubernetes authentication. So there's multiple secret engines that you can enable in Vault, and one of them is the Kubernetes. And in the Kubernetes authentication method, you can basically configure a service and an endpoint, and also roles. So this will allow you to access your Kubernetes service, and here it is, configure. So here you can see here's my Kubernetes host, and you also normally have a Kubernetes CA certificate. You can't see this once you put it into the UI. I also did this with Terraform. So you need to retrieve this once, and then your Kubernetes cluster can theoretically authenticate against Vault. So this basically then gives you the option to add roles. So we have like these authentication roles or auth roles. I have two. So we're going to create two applications today: deploy env, deploy environment, and deploy volume. Deploy env is going to be our green application. Deploy volume is going to be our blue application. I'll just show you one so that you see basically the idea. It has a service account called web app SA, and it's going to be installed in the namespace deploy env. And at the bottom, you should see that here is the token policy. So I also have a token policy. Here's the policies. And you can see that this is the reader policy, which I configured. And you can see that in the secret path K8s, this is what my secret path's called. You can call it anything that you want to. And I just put an asterisk here. You could theoretically put this down to like only one individual secret. This, of course, would allow him to read and list all secrets. And as I said, all of this was configured using the Terraform provider. Okay, so let's have a look and see what this looks like on the shell. And I'll quickly show you how this works. Can everyone see this? Is this big enough? So we basically, it's okay? Yep. So we basically have a Kubernetes cluster here with 3 control plane nodes, 4 worker nodes, and some local storage nodes per Ceph. This is basically it. We have a few namespaces. I've removed all the namespaces we're going to install here. And first up, we're going to install the CSI driver. So I'll quickly type this in, and once it's started going, then I'll quickly show you the options I'm installing it with. So I'm going to install this into the CSI secret namespace, CSI secret store, sorry. And this should bring up a daemon set. So we'll have a pod running on each node and set my storage nodes. I'll show you why in a minute. We can actually do this while we're still waiting for this to get done. And we can have a quick look. And if we look at the CSI driver, then you will see that I have excluded certain nodes. So with the anti-affinity and node anti-affinity, I've said, okay, do not install on the local storage nodes because I don't need them there, because I'm not running any application pods on there that retrieve secrets. The only other thing I changed is I enabled the sync secret, and I basically changed the rotation pole interval. Normally this would be on about 5 minutes, but imagine us waiting for 5 minutes until I can change the secret. This would be a long time for me to stand here and wait. So I changed this to 1 minute. Otherwise, probably 5 minutes is absolutely sufficient if you're running this in production until your secret will have reflect the change that you just made. So let's have a look and see if this worked out. If so, then we should have a CSI secret store. And if we get the pods, we can retrieve them all. Yep, they're there. So next up, I will quickly deploy both of my applications, and then I will quickly explain what's happening while they're going. Because as I said to you, the applications need to create a an SSL certificate, sorry. They need to add their IP address to the DNS server. This is all going to take a while. So I'm going to do this, and then I'll explain to you what I've done. So this was the green application, deploy env. This is my blue application, deploy volume. And now I'll go through the applications with you. So number one would be deploy environment. So this basically uses a standard deployment. The only thing I basically changed here is the service account, which I showed you earlier. This is the account that I'm referencing in Vault. So this is important that you set up your own service account. And what I'm doing here is I'm writing out an environment, so standard Kubernetes stuff, and reading web app secret with a key password. And the only difference that you probably haven't seen yet is that the volume type is secret store inline. If you look at the bottom, then you will see that this is basically this CSI volume, and the driver is secret store CSI. So this is something new, which you wouldn't have in a normal Kubernetes cluster if you haven't installed this software. Actually, I didn't even show you this. So after installing the Helm chart, let's have a quick look. CRD, grep secrets. Then we should see, CSI secrets maybe, or just CSI. Then you see we have two new custom resource definitions. These both come with the Helm chart that I installed first. So next up, I'll quickly show you the secret. So this is basically the secret. So we have this new CRD, secret provider class. The namespace is clear. It's going on our environment. So in our green application, my provider is Vault that I'm using. So this can be one of the, I think, 3 or 4 built-in providers. I'm going to focus on Vault here. And I'm writing a secret object, key, password, object name, and also the secret name that you saw earlier. Here's my Vault address, vault.metacube.org. And as you can see, I'm also writing a secret, which, because you can see secret name is web app secret. Remember this? Because you will see this is one of the key differences to the second improved, or I find improved version of the application. So let's have a quick look at this then. We'll look at the YAML of application 2, which would be our blue application, deploy volume. And you will also see that the setup is very similar. One of the big differences that you probably can see already is that we're not reading a secret. So we have a volume here, the same as the other version. We're using the CSI driver, but there's no reference to the secret in here. And if you look at the secrets store, you can see that we are actually writing a secret, but there's like no secret name here. So we're not actually writing a Kubernetes secret. This is one of the big benefits of this second application. If I'm not writing it out as a Kubernetes secret, it's not going into etcd, and there's no way of anyone stealing it there, because it's only in our pod. It has, of course, a few trade-offs, which I will talk about in a minute, but this is basically the way this works. So let's go back to our first application. So deploy environment. So let's check if our pod has come up. It has, and our pod has got a secret. Yes, let's see if we can decode this secret. Yes, we can. Our secret is container. This is how you can basically decode a standard Kubernetes secret. And if we have a look, we should be able to also retrieve this secret from the disk. Because as I said earlier, we're mounting the tempfs volume. So I can read this secret from the path MMT secret store web app path. This, of course, is configurable. You could put it in any other way as well. You could mount it somewhere else if you wanted to as well. This is also an option. And you will also find this secret in the pod's environment. So if anyone can actually access this secret, then you will find it in the, here. Oops, wrong pod name, sorry. You will also find this in the pod's environment. So here, you can see next to some of the other Kubernetes stuff, web app secret is container. So we've solved this. You can see that we're writing out a Kubernetes secret, but we're also writing our secret to the volume. Let's have a quick look at the second application. So I find this is an improvement. We are not writing any form of Kubernetes secret. The only secret you see here is the TLS secret that we created, but no Kubernetes secret. You should be able to retrieve this secret from the volume as well, but you won't be able to see it in the environment because it's not there. It doesn't exist in the environment. So let's quickly have a look at our web application in a browser and see what it actually does. Hopefully this has all worked. This is our green application, and it's got container here, and this is our blue application, which is only reading the secret from the disk. So of course, you're going to have to modify your application to ensure that your application can read a secret from a disk. It's like slightly different than reading it from a standard Kubernetes secret. But if you're handling your own secrets, this should not be a huge problem. And next up would be we go and change our secret. So let's just go into Vault. Here's the K8s. Here's the web app with my secret. And here you can see container. So let's just create a new version of this. So we delete the standard secret. Oops. No. And save it. And what would you guys expect to happen here in a minute's time? Do you think we're going to see any changes within the secret, even though I've changed it and I've used like the rotation? Absolutely correct. The guy in the center is already shaking his head. No, you won't, because the secret is mounted into the pod. So the only way that you could actually go and change the secret would be to actually change the, restart the pod. Otherwise, you're never going to see a change of the secret because this is already mounted. We need to restart everything. The thing is, do you want to do this? Or would it just be easier if your pod can retrieve the secret on its own from the disk, no restarts anymore, maybe a few minor changes to your code, but otherwise there's nothing else that you need to do here. And if we want to quickly see if the secret will be written out to the other container, we could do a restart. So we could basically do something like this, rollout restart, deployment env, this will restart the pod, which of course in my case, this is a demonstration, will take this pod, which will take this pod offline. And this should then reflect our change of the pod once the pod comes back up again. So this is going to take a few seconds. There's a bad gateway, and there's our ContainerDays 2023. So doing this, well, number one takeaway is your secret is not written anymore to etcd, so you don't have to take care of, you still should take care of securing your etcd, but it doesn't include all your secrets. And number two, you should be able to retrieve these secrets in a running pod as well, if your application allows you to do this, if you poll this like every few minutes. Okay, so this is the end of my demo, and I should be ready to take some questions if there are any in the audience. Thank you very much for listening. And if there's any other questions that you think about later on or so, please drop by and talk to us at the booth. There'll be me and some of my colleagues from Sys11 there if you're interested in managed Kubernetes or OpenStack. Thank you.
Thank you very much for the talk. We don't have that much time left, but let's see if we can answer as much question as possible. So the first one, CSI, when a secret is rotated, how to ensure the application running is using the new secret? This is what you just showed, I guess.
Yes, this is what I just showed. So I think we can probably skip this question. It's statically mounted into the pod in the first use case. You need to restart it. Otherwise, you can retrieve it from the volume if your application supports doing this.
Interesting one. Are there any other self-hosted secret providers?
I don't know of any, to be honest. I think some might evolve after the change of license. Do any of you guys know any other KMS providers? You do? Okay. Which are open source?
Actually, I do. There's a tool called Conjure, C-O-N-G-U-R-E, built by, I can't remember the name of the company. And it works kind of the same as Vault. It's not that well known, but it's open source, and it has an open core versions as usual.
Yeah, maybe give it a try
then. How is the service account secret protected? Is it a plain Kubernetes secret? Well, good question.
You mean how is the secret? How's the service account secret? It's a plain Kubernetes secret. So the service account is now protected by the token API. So basically, you can get a new token every time. This is something new, which is introduced to Kubernetes in 1.27, I think. So you don't need these static tokens anymore.
Let's go for the two last questions. I'm sorry, there are 3 more waiting, but we won't have enough time to answer them. So for everyone who has more questions, please join Sys11 on their booth, just to, let's say, continue the discussion. Being mounted as a volume, doesn't that mean that the secret will be visible on the host file system?
So it's a tempfs volume. So in theory, this tempfs volume could be mounted by another service as well. This would theoretically be possible, yep. Definitely.
And one last question. Can the secret in the CSI volume be deleted after service started? Jenkins, for example, only needs to read the secret at startup.
Yeah, that's one thing I actually forgot to mention within the feature list. This is something the CSI provider takes care of for you. It actually deletes the tempfs volume once a pod is stopped. So this is nothing that you need to take care of yourself. Pardon? If you're allowed to mount this pod and you can mount this CSI volume, then you can do. Yeah, if it's running as like
the same pod in the pod.
So,
can run a Jenkins job.
So you're running Jenkins inside the pod.
Yes.
Okay, it wouldn't be something that I would recommend doing, but if you really want to do this, then I don't know, because I don't really run Jenkins, to be honest, anymore. It's like 15 years ago the last time that I touched Jenkins, but. Well, if a GitLab CI pipeline doesn't have direct access to your pod in all questions. You've got a runner, and you deploy something to your Kubernetes, and depending on, of course, normally it would run with a very high privilege, so definitely you could access certain things. I mean, if you're running a CI job with privileges which equal to cluster admin, you can access anything in the cluster. And you can also delete everything, which is normally what a lot of people do because they want to create and delete namespaces.
Sorry, we really have to skip.
But we can follow up on this in a minute if you want.
Just follow on. And again, thank you very much for this talk. And please, can I have a big round of applause for our speaker?